What if the next soldier on the battlefield isn't a person? What if it is a machine that can hunt, identify, and kill without a human ever pulling the trigger? This is not a question pulled from science fiction. It is a question being quietly asked inside defense departments, research labs, and intelligence agencies right now. The future of war is not arriving with loud mechanical footsteps or humanoid robots. It is arriving as software updates, tiny flying machines, and invisible data streams. The building blocks for autonomous war are already here. They are being developed for efficiency, safety, and cost reduction. But when connected together, they create something far more powerful and far more dangerous. The battlefield has already changed. The modern battlefield already looks nothing like the wars of the past. Conflicts like the war in Ukraine have demonstrated that large numbers of small, inexpensive drones can dominate even the most sophisticated militaries. These machines are used for reconnaissance, targeting, electronic warfare, and increasingly for direct strikes. They are easy to replace, difficult to stop, and constantly evolving. A drone that costs a few $100s can destroy equipment worth millions. That simple economic reality has forced every military in the world to rethink how power is projected. Instead of building fewer and better machines, they are now building more and cheaper ones. Instead of relying on human pilots, they are investing in systems that can operate with minimal supervision. Instead of focusing on individual platforms, they are designing swarms that move and act together. The battlefield is becoming less about who has the strongest weapon and more about who has the smartest network. Artificial intelligence as a weapon system. At the heart of this transformation is artificial intelligence. Modern military AI is not just about analyzing data or optimizing logistics. It is being built to make decisions in real time. Programs like the U.S. Air Force's Collaborative Combat Aircraft are designed to fly alongside piloted jets, navigate complex environments, and carry out missions with increasing independence. These systems can already plan routes, avoid threats, and coordinate with each other. The only thing they do not officially do is decide when to use lethal force. But the line between guidance and decision-making is thin. If a system can identify a target, track it, predict its movement, and maneuver into position, how much human input is really left? In practice, the human becomes a supervisor watching a screen while the software does the work. Over time, that supervision becomes symbolic. The faster the system moves, the harder it is for a person to meaningfully intervene. Seeing without eyes. To hunt a target, a system must be able to see. But in the modern world, seeing does not always mean using a camera. Researchers have demonstrated that ordinary wireless signals, like Wi-Fi, can be used to map people inside rooms. As radio waves bounce off walls and bodies, algorithms can reconstruct where individuals are, how they are moving, and even how they are breathing. This technology was developed for healthcare, security, and disaster response, but it has obvious military applications. Combine that with cameras, infrared sensors, and facial recognition, and you get a system that can detect and identify people in almost any environment. A drone does not need to know who you are by name. It only needs to know that you match a profile. That profile could be a face, a gait, a phone signal, or a pattern of movement. Once identification becomes automated, the act of tracking becomes trivial. A machine does not lose focus. It does not get distracted. It does not forget. It follows data, and wherever the data leads, the machine follows. Scale changes everything. The final piece of this system is scale. Militaries are now planning to deploy hundreds of thousands of drones. Not expensive, carefully maintained machines, but disposable ones. They are meant to be lost. They are meant to be replaced. Their value is not in any single unit, but in the mass they create. When you combine scale with autonomy, you get something entirely new. You are no longer controlling individual machines. You are managing a flow of them. They are launched, they spread out, they communicate, and they act. A human cannot direct that many units in real time. The only way it works is if the machines make their own decisions. At that point, the concept of a single assassin drone becomes meaningless. The system is the weapon. The network is the weapon. And once it is activated, it does not need to be guided. It only needs to be given a general goal. The ghost in the system. The moment machines are allowed to make decisions about force, even in limited ways, something fundamental changes. Warfare stops being entirely human. A human may still define the objective, but the process of finding, tracking, and selecting a target begins to happen inside software. This creates what many experts call a ghost in the system. It is not a consciousness. It is not evil. It is simply a network of algorithms operating at speeds and scales no person can match. When such a system acts, there is no single mind behind the action. Responsibility becomes fragmented. Was it the programmer who wrote the code, the commander who authorized the mission, the technician who launched the drones, or the machine itself that made the final choice? In a world of autonomous systems, accountability becomes blurred, and that is one of the most dangerous changes of all. International law is built on the assumption that humans make lethal decisions. Courts, treaties, and war crimes investigations all depend on the idea that someone can be held responsible. When a machine makes the final call, that structure begins to break down. There is no way to question an algorithm. There is no way to put a line of code on trial. The more autonomy machines are given, the harder it becomes to assign blame when something goes wrong. Widespread is the real danger. Most discussions about autonomous weapons focus on what powerful militaries will do with them. That is only part of the risk. The greater danger is what happens when the technology spreads. Every piece of this system is becoming cheaper and more accessible. Commercial drones are sold worldwide. Facial recognition software is widely available. AI models are open source. Wireless sensing is being researched by universities and startups. None of this technology needs to be smuggled out of a secret lab. It already exists in the open world. As costs drop and capabilities improve, small groups gain access to tools that once belonged only to governments. A targeted attack no longer requires a team, a base, or even a border crossing. It only requires proximity and data. In this new world, violence becomes scalable. One person can deploy many machines. One machine can track many targets. Attribution becomes nearly impossible. If a drone appears in a city and causes harm, who is responsible? There may be no clear answer. The machine might not even belong to a state. It might have been assembled from parts ordered online and software downloaded from the internet. Why regulation lags behind reality? There are international efforts to restrict autonomous weapons. Diplomatic groups debate bans on so-called killer robots. Ethical panels discuss whether machines should ever be allowed to make lethal decisions. But technology moves faster than treaties. By the time rules are written, the systems already exist. Unlike nuclear weapons, autonomous systems do not require rare materials or massive facilities. They require code, sensors, and manufacturing capacity that already exists in the civilian economy. Even if major powers agree to limits, enforcement would be nearly impossible. You cannot easily inspect software. You cannot tell what level of autonomy a system has just by looking at it. And even if one country restrains itself, others may not. In a competitive world, no military wants to be the only one holding back. The fear of falling behind pushes everyone forward. That is how arms races begin. Not with evil intent, but with mutual suspicion. Why this feels different? Every new weapon has been frightening, but autonomous systems are different in one critical way. They remove the human from the final loop. That means speed, scale, and persistence increase beyond anything we have seen before. A machine does not feel fear. It does not question orders. It does not hesitate when a target appears. Once a system is activated, it does exactly what it was designed to do. If that design includes identifying and neutralizing a person, it will do so without reflection. And if it makes a mistake, it will not realize it has done so. This is not about malice, it is about optimization. Algorithms are built to achieve objectives as efficiently as possible. If the objective is to eliminate a target, the algorithm will pursue that goal with perfect focus. The future arrives quietly. So is the military's secret assassin drone already here? Not as a single machine, but every critical component already exists. Artificial intelligence, autonomous navigation, advanced sensing, facial recognition, and mass deployment are all real and improving every year. We are not waiting for a breakthrough. We are watching an assembly. Each new capability clicks into place. Each new program adds another layer. And once the system is complete, it will not announce itself. There will be no moment when the world suddenly realizes what has happened. The machines will simply be there. The assassin drone is not a single device. It is a network of technologies that now exist in the world. And whether we are ready or not, that network is growing.